Hi, everybody. Happy Thursday, unofficial last day of reInvent. How y'all doing? Okay, all right, that's the energy. Okay, I was actually watching some of the talks that my coworkers presented on Monday morning at 8 o'clock, and there's nothing. There was silence. That was so devastating for me to watch. This will not be like that. We are friends up here, and we're gonna go on a journey today through infrastructure as code and governance, and it's gonna be very fun. But before we get into all of that, I do have some questions for you all because this is an us situation. This is not a breakout session. They won't let me do those anymore. This is a us session, so if you have any questions at any time, you just say, David, Sefi, and we'll be like, what's up? Speaking of David, I'm David. My name is David Kilman. I'm a principal engineer in AWS, specifically infrastructure as code, so things like CloudFormation and Terraform and CDK. Quick survey, who here uses infrastructure as code? Oh, that is a beautiful 100%. Maybe. We actually can't see up here because of the light, so the narrative will be changed to suit the talk. A quick survey, who uses CloudFormation? Okay, I see you. Who uses Terraform? Nice. Who uses both? Oh, yeah, I like this guy. Cool. Oh, any Pulumi? Any Pulumi people? They had the best swag that's why I asked. Okay, anyway, so my name is David Kilman. I am a principal engineer on CloudFormation, and today we're talking about infrastructure as code, governance, making deployments of IAC safe, and I am joined today by Sefi. This is my friend.
Hi, nice to meet you all. I'm Sefi Avrech. I'm a senior solution architect. I'm working with governance and compliance and security. This is the sides that I'm covering here. And let's get started. OK, so we're all familiar with this pattern. You write in some code, write some CloudFormation, some Terraform. You push it to your Git. And then there is CI/CD pipeline that start running, right? And you have your resources deployed inside your AWS account. We're all familiar with it, right? This is how we work. Great. But how do we implement some guardrails around this situation? And this is what we're going to talk about today. We will run this slide, so we go to the code directly. So developers are moving very fast, right? You all use, I believe, generative AI to generate code to help you with the infrastructure. And we need something to help you stay in the guardrails of your organization, the security requirements, cost requirements, even machines image requirements. So let's see if the car is working.
Yeah, this took us a few hours to put together.
Yeah, it's working. Inside the guardrail.
Yeah, please hold the applause until the end.
So what we're going, this is when CloudFormation Hooks is coming to help us. Huh? Oh, dude.
It's so good, we wanted to show you twice.
You make it so good.
Yeah, there you go.
See what automation don't do? Cops do. So on the left side, on the right side, you see the simple CloudFormation template. We're going to create a resource, and it's going to be failed. Okay, it's going to be failed because it's not stand in the organization requirements. Okay, and now I'm passing to David.
Well,
give us some use cases.
Yeah. Cool. So whenever we talk about failing things, Sefi always sends it back to me. Today we're going to talk about infrastructure as code and how proactive controls can stop bad things from happening. So we're going to talk about hooks. Hooks is a CloudFormation feature. I work on CloudFormation. They sign all of my paychecks. But we also realize that infrastructure as code spans beyond just CloudFormation. So we're also going to talk about Terraform in a bit. So for the first part of this talk, we're going to do a lot of demos in CloudFormation, but Sefi's going to show you how things work in Terraform as well. Anytime I type Terraform apply on my Amazon issued laptop, it lights on fire. So Sefi will be doing the Terraform stuff. But the root of it is proactive controls are the same across all of IAC, right? And what are proactive controls for? I think probably the most common and most important reason we talk about proactive controls is around things like safety and governance. And we want to stop bad things from happening, basically, right? So if you look at this slide, it's like a really simple slide, right? This is on the left is a CloudFormation template, and this is the simplest CloudFormation template I could write. It just creates an S3 bucket. And on the right, you can see that like if I tried to provision this bucket, it actually fails because there's no bucket encryption enabled, and that's totally fine, right? Like I think. Quick question for the audience, like who here considers themselves like security people? Like security is part of my responsibility, cool. How about platformy people, like the platform team? Okay, cool, yeah. So, right, like we see this a lot. Like I'm an engineer, and I don't know if you can tell, like I kind of just do stuff very fast. I basically try to find the fastest way to make things work. And I don't always think about the platform. I always think about security, but sometimes I omit security in the name of speed, like this bucket. Yeah. I think like all of us in like security and like platforming teams are familiar with like this trade-off, right? Like developers want to go really fast, but like we who own the platform or get paid for security incidents don't want to sacrifice like the platform security or like governance or like compliance. You know, tons of organizations have things like FedRAMP compliance or like NIST compliance, all these like compliance packs which require you to be like always put on bucket encryption or like enable object lock on your S3 bucket, right? Like these are kind of like really nuanced like configuration options that we don't really want to have that conversation with developers every time they want to create an S3 bucket that they have to turn on SSE encryption for their bucket, right? We want to make sure that they can move fast, but like not break our platform. So hooks and like proactive controls help stop bad things from happening before they happen. I'm going to tell you a story. We're going to have a lot of stories, and they're all going to be a little embarrassing about me or interns. But a long time ago, does anyone remember when Lambda launched function endpoints? A long time. It was like maybe 2 or 3 years ago. Does anyone here not know what Lambda is? It's totally fine. Do we got our Lambda? Okay, cool. I love Lambda. Anytime, reInvent's very fun for us as well because this is the first time we're hearing about a lot of new features. So I remember a few years ago at reInvent, Lambda launched this feature called function endpoints. It basically lets you like generate an HTTP URL that when someone calls it, like sends a GET request to it or a POST request or something, it invokes a Lambda function. And I thought this was super cool. And it was like really easy to set up. And this was sort of back before things like hooks existed. And so I was experimenting. I was trying to like set up this like Lambda with a function endpoint, and it was actually really fun. I had it like the Lambda function send a text message to my manager saying that you should give David a raise, and then I posted the URL into like our organization Slack channel, and everyone kept clicking. It was really a beautiful day, but it was really fun for me because I got to like experiment with this new feature. I had a lot of fun with it. The cool thing about function endpoints is that there's also a lot of configuration that you can do for security. You can say, hey, like only like this IP address range can call this endpoint, or like it has to be within this like VPC and it's private. Those are really cool, and I did not care about them because like I just wanted to get it to work. I wanted to make a funny like joke for my coworkers and send like this link out. So I did that, and it was fun. And then I was going home. And I was on the train, like listening to, I don't know, some podcast or something, and like I got this I thought it was like an Amber Alert, but I was actually getting paged, and I was like, I am not on call. Why am I getting paged? And it turns out like we had this reactive, this detective control system that like scanned our AWS accounts every hour or so to make sure that like all of our resources were compliant. And it turns out like our security team had decided that like a globally accessible function endpoint that costs money when it is invoked, that's just accessible by anyone, was not compliant with security. So I had to like get off the train and like go find a coffee shop and like go like read this ticket that I got paged for and like go disable this, delete this function. I was really mad. Actually, this is the thing that radicalized me on proactive controls. This is why I care about it so much. Because I was like, how did you just let me create something that you knew was wrong, right? So that's where proactive controls comes in. Like that experience for developers, it kind of sucks, right? Like you page, like if you create a resource and it is misconfigured and you just let it happen, like that change can propagate through pipelines, it can go to production, and reactive controls and detective controls are amazing. They're like, They always catch things, but proactive controls are better because they can stop things before they happen. So that's why I love proactive controls, and that was just a long story to say that proactive controls are really good for governance. Another thing that proactive controls are really helpful for are stopping you from making accidental mistakes. So in this example, I have a CloudFormation template with an autoscaling group. And my autoscaling group had a minimum of 1 EC2 instance and a maximum of 100 EC2 instances. So in CloudFormation, you can create this thing called a change set, which is very similar to a Terraform plan, which basically just says, hey, I'm transitioning from like this state to this other state. So in this case, I had a hook that was running that when I tried to make this change, failed. It failed because the hook had logic in it that said, hey, whenever some sort of like capacity change happens on a bunch of resources, so like CPU, memory, IOPS, like auto-scaling group sizes, whenever those changes happen and they exceed 50%, I'm just going to fail, right? Because this is production, like you're changing things really drastically. In this example, it actually wasn't me. I didn't make the changes. I'm not the villain of this particular story. We had an intern. This intern was so smart, much smarter than me. And one of the things that our intern was doing was they really wanted to like deploy our service to their own, like we give all developers at Amazon, they get an AWS account that they can do anything with. So they wanted to deploy our service to their own personal account. And I was so excited because I was like, yay, bias for action. This is fun. You're going to experiment. And this intern also was like very frugal. They're like, I don't need 100 EC2 instances being spun up in my account. So they actually changed their template to make it so that like the number of auto-scaling, the EC2 instances that could be provisioned was 10 instead of 100. And through a series of unfortunate accidents, they accidentally committed this change to our repository, and our pipeline picked it up. And our pipeline started to try to deploy it to our beta stage, and then that's when this hook was invoked and stopped that change from rolling out, which was great, because if our service, CloudFormation powers like hundreds of thousands of deployments, so if we had only 10 EC2 instances to do that, that would have been a very difficult day for our on-call. The other nice thing about, the thing I like about this story is that Amazon has like this culture called like COE culture. Are folks familiar with COEs? They're just basically like when something goes wrong, we write this doc that's like, what went wrong? Why did it go wrong? And like most importantly, how do we stop it from happening again? And the reason we had this hook written for our team was not because I'm really wise and a wonderful platform engineer and foresaw this. It's because we had a COE like a couple of years ago where another intern had done something very similar. So the nice thing about like our like COE process is we have these tenets that our action items should not be best intentions, right? So an easy action item is like update a run book, and that way when our intern comes back, they'll follow the steps to make sure that they do the right thing. We call those like good intentions, and like sometimes they're fine, but we always are searching for mechanisms. Like how can we enforce that this bad thing does not happen again? So with things like hooks, you can take your learnings from different types of outages, like overeager interns, or maybe like careless engineers, and codify them and enforce them in your IAC. That way these mistakes don't have to happen again. Okay, I'm going to go over one more use case that my manager insisted I put in as a punishment. So the other great thing that like proactive controls can do is make sure that you don't spend too much money. Sometimes engineers provision extremely large EC2 instances because they're not responsible for their AWS bill, and they just leave them in their account and run up huge bills. That is something I have done. So now we have a hook on our team only that makes sure that like there's a set of allow listed EC2 instances that we can deploy. My manager made me do that because we had a huge bill. But our actual practical reason why folks would do this a lot is, a lot of organizations do a lot of negotiation with Amazon to make sure that we have like savings plans or like certain EC2 instances that we get discounts on. And that's really hard information to like trickle down to engineers or people who are building platforms to know that like, hey, you should only use this particular type of instance because we get a discount on it. So that kind of information can be codified in like a proactive control that says, hey, like you didn't do anything wrong. It's just that you tried to, like there's a better instance type that you can use that we get a discount on. So proactive controls can help you with things like governance and security. They can help codify best practices and learnings from COEs. They can help you make sure that trickle down organizational best practices like cost best practices. So they're really useful, and they're kind of I think they, in the IAC world, they're super valuable. And I think in CloudFormation and Amazon specifically, we're only just in the past couple of years really understanding how valuable these are. So I'm excited for us to get together and experiment with them. Cool. So you thought that it was cool that I was talking for so long, but now we're actually going to code because this is a code talk. So in this code talk, we're going to do a couple of things. I'm going to teach you a little bit about CloudFormation Guard. This is our policy as code DSL. There's nothing really special about Guard here. You can replace it in your mind with any policy as code language that you're familiar with, like Sentinel or Rego or Chekhov, whatever you're comfortable with. Conceptually, they all do the same thing. I'm going to show you how to build a hook using Guard. We're going to go through a beautiful journey of trying to deploy a CloudFormation stack, a process that I'm sure we've all experienced and enjoyed a lot. And then I'm going to show you how we can not do any of that and just use a couple of clicks to build a hook using something called the control catalog. And of course, we're going to show you how to make it work in Terraform too, which is going to be fun and delightful. But now we're actually going to do all that stuff. Cool. So yeah, switch. OK, I'm going to assume my official coding position, which is sitting on this chair with my knees. Cool. Yeah, let's get into it. Let's build stuff. OK, so also, Amazon has this thing called connections where every day they ask us a question, and you cannot stop it from happening, and it always pops up during presentations. So I'm going to move this over here, and we're just not going to talk about it anymore. OK, cool. So let's set up some proactive controls for IAC and show how they work. All right, so let's go to CloudFormation, which is my favorite IAC service that's natively hosted on AWS. I talk a lot of smack about Terraform, but I actually love it, so please don't take it personally. I'm going to close every single notification that came up because we were very eager this year to launch a lot of features. And I'm going to go to our hooks section. So this is our hooks page. This is a 3-step picture that explains in what took 20 minutes to explain. So this is always delightful if you ever forget and don't feel like listening to this talk again. It just shows how a hook basically sits in front of CloudFormation doing something and evaluates if that thing is good or bad. If it is bad, it stops that bad thing from happening. So I'm going to actually go down here, and we're going to create a hook. And we're going to use Guard, because that's my DSL of choice. And OK, so over here, it tells us, hey, you have to upload your Guard rules to S3. And so this is a code talk, so I'm supposed to be coding, but I'm remarkably lazy, so we're not actually going to write these rules ourselves. So there's this community on GitHub of pre-written Guard rules, which are super cool. So I'm actually just going to go steal this from our Guard rule registry. So this is GitHub. If we go into the rules, you can see that there's a bunch of different AWS services, so like Amazon S3. This is one of my favorite ones, so I'm going to click it. And you can see that there's a bunch of different files that map to a policy. So we have S3 bucket default lock enabled. S3 bucket logging is enabled. There's a bunch of, well, let's see, what is a good one? Ooh, bucket versioning enabled, that's kind of fun. So we're going to just, I already took a few of these, but I just wanted to show you. There's a bunch of different services over here. Let's see, IAM exists, which is always a fun one. And IAM has a bunch of, IAM is probably the place where you can do the most damage from a security point of view. So there's a lot of really fun, policies written already for IAM, for example, no admin access, which is delightful. We should not have admin access for a lot of things. So, what I did earlier for demo magic purposes is I cloned this repository locally, and I took a couple of rules from that repository. So I have some DynamoDB, some IAM, some Lambda, some S3, and I just zipped it up. And then I uploaded it to S3. We never know what the Wi-Fi situation is going to be in these rooms, so I try to like pre-buffer as much as I can. So I'm going to go. I uploaded my guard rules to S3 earlier, so I'm going to select this, and I'm going to tell guard to write a bunch of logs whenever something fails, and we're going to call this something. This is fun. Does anyone have a fun name for this hook that we should call it? I'm thinking very good hook. Does anyone have any other suggestions? What? I don't know. I don't know what I expected from that. I heard someone say, I don't know. I heard gotcha hook. I like that because it's like pew pew. I gotcha. So we're gonna call this the gotcha hook, and hooks can run in a lot of different places. So before a CloudFormation stack is updated through Cloud Control API at change sets, for this, we're going to just do resources. So anytime CloudFormation goes to provision a resource, it's going to run these guard rules to make sure that resource is compliant. And I'm going to tell hooks to run this whenever a resource is updated or created. And there's this thing called a hook mode. So a hook, I'm going to change it to fail. So basically, anytime this hook evaluates to false, it blocks something. You can also put a hook in warn mode. So like a hook can fail, and it doesn't actually block something. So this is really good if you're like authoring new rules and you want to test them out without necessarily blocking people. But for this, we're going to block it. And I'm going to create a new role called the gotcha role. Cool. You can have hooks be really specific on exactly when they run. I'm just going to have it run all the time. And I'm going to create this hook. Yay, cool. OK, so I created this hook. It's running in my account now. Fun question. Has anyone here used GenAI for IAC stuff yet? OK, cool. Yeah, it's fun. It's fun. I also used GenAI for IAC stuff for this talk. I asked Kiro to generate for me a template, a CloudFormation template. And my prompt to Kiro was basically like, I want a really simple CloudFormation template that creates a Lambda function, a DynamoDB table, and an S3 bucket, just to create a really simple application that writes to DynamoDB and pulls files from S3. And this is the template that it gave me. It created a Lambda execution role. This is the role that Lambda will use to do stuff. It created a Lambda function, so a simple inline function using Node.js. Sure, that sounds good. It created an S3 bucket with no properties. Fine, that is a correct bucket. And it created a DynamoDB table. And the thing that I like about this template that it generated is it tried a little hard, right? Like it turned on point-in-time recovery for me, which is a really nice gesture. I do appreciate that because you don't want to accidentally delete your DynamoDB table and realize you don't have point-in-time recovery turned on. So this is a great template. And I think maybe as I was scrolling through this, the security people may have lifted an eyebrow. Or maybe folks realized that I was alluding to certain things earlier with this S3 bucket. But we're gonna try to deploy it to CloudFormation and see what happens now. So I'm going to go take this template, call it from the web. Oops, sorry. Cool. Next. Oops, sorry. I don't. Sometimes the AI doesn't always create perfectly valid CloudFormation. OK, so that one works. OK, we're going to call this, this will probably work. And I'm going to just power through all these prompts and tell it to do stuff. And it's going to start creating stuff. Ooh, does anyone have any feedback for CloudFormation? We'll get to that later. We love feedback. OK, cool. So CloudFormation tried to create my stack, my DynamoDB table, and it failed. So if I scroll through all of what happened chronologically, is it started creating this Lambda role, S3 bucket. But before it did anything, actually called the service APIs to create a bucket or create a Lambda function, it invoked our gotcha hook. And as you can see, the S3 bucket failed to create because the gotcha hook failed. So if I click on this, we can see that this hook failed with the message that the template, we had a rule called S3 bucket lock enabled that failed, a rule called S3 bucket read prohibited that failed. So I guess we're going to have to fix that. So if I go into like the hook, you can see like, all right, here's the details of this particular hook run. I had a bunch of, we had the Lambda rules and the DynamoDB rule and the IAM rules. They did not run because this is an S3 bucket, but the S3 ones did. And I'm going to click this S3 bucket lock enabled real quick. And it kind of gives us, it tells us exactly what went wrong, right? So it says the check was not compliant because the property of S3 bucket properties, object lock, is missing. And we have this little helpful hint saying, hey, like the violation is that S3 bucket object lock was not set, and we should set it to true to make this check pass. So just to, I'm going to show you what this rule looks like. Let me see. Oh yeah, so here it is. So this is a guard rule. So this is all comments, but it's just, this is describing what this rule does. So this is my object lock enabled rule. And what this does is every time this rule runs, it takes as input the CloudFormation resource that's getting provisioned. And we say this rule applies if any resource type is of AWS S3 bucket. And our rule says that S3 bucket default lock must be enabled. And it says when it has found a resource of type S3 bucket, assert that there is a property called object lock enabled, and that the property object lock enabled equals true, right? And you can see in this like guard rule, I have this like freeform text here. It says like violation. Hey, like if we get here, that means that the object lock enabled property did not exist, and it needs to. So we can set this feedback. And if the S3 bucket lock enabled existed but was not true, we say, hey, you have to set this to true. And you can see like this is the data that pops up right here. So you can be as specific or as like cryptic as you'd like to be with your hook feedback. But this is a really good example. I think this is really good feedback from me because it's really clear what happens. It's looking for this object lock enabled property, and it is looking for it to be true. So let's go back to our template and help Kiro a little bit. So I'm going to add a property called object lock enabled, and it says it should be true. I don't know what object lock enabled means, but my platform administrator, who is very wise, said that we needed it. So I'll believe them. Actually, I do know what object lock enabled is, but it is very cool. So like it's really an interesting feature, but critically, I'm putting my platform hat on now. Like you can only enable object lock on S3 buckets when you're creating the bucket. So this is actually a really good rule because you cannot add that feature after the fact. So we're going to try creating the stack again with my new and improved template. And we're going to call it this will def work. You can see that I go through this experience pretty often. So I'm just going to power through the CloudFormation console, and we're going to say submit. And we're going to see again what's happened. Boop, boop, boop. Oh, it failed. OK. This is not too surprising. We knew some things were going to fail, but I just wanted to see what it looked like now. So if we go back to our hook, you can see now our S3 bucket default lock enabled experience worked. It was fixed, and it passed. But we still have this other rule that failed called S3 bucket read prohibited. And if I look at this one, it's a little more complicated. So it's saying, like, it was looking for this property called public access block configuration and the properties of this S3 bucket. And there's a couple of properties it wanted to be set. So like block public ACLs, block public policy, ignore public ACLs, restrict public bucket access. It wanted all of those to be true. So I think buckets being public is bad in general. So I think as platform teams and security folks, we are always really excited when folks want to make sure that their buckets can have absolutely no way of having public access. So by setting all of these values, we can to true, we can make that a reality. So let's go back to our little S3 bucket, or I have this public access block configuration. I'm just gonna I'm just gonna copy straight from this output. Boop, boop, boop. And I'm going to say true. All right, cool. So I did that. That was fun, and I'm sure you all were really excited for me to go through the create wizard again, but we know there's more things that failed, right? Like if I go back to our template, the DynamoDB table failed, the Lambda execution role failed, let's see, DynamoDB table failed because table must be encrypted. So this is fun, and I enjoy coding with you all. But as a developer experience, waiting for my stack to create a resource and then iteratively trying to fix it is not great, right? Like, I think this stack is really fun because it's serverless, it's using Dynamo, it's S3, it's really fast. But if I was using something like ECS, which when you create an ECS service in CloudFormation, it waits for the deployment to actually be done before it considers the resource successfully created. That can take a while. That can take a few minutes. If you're creating a CloudFront distribution, that also can take minutes. So your stack execution time can take a while, and you don't really want to find out that the template that you're building was not compliant only after minutes, 20, 30 minutes. We want to know as early as possible. So this is fun. Instead of going through and iterating on this template one by one, trying to fix all these errors, I'm going to show you a fun trick. So we're going to go back to our hook, our gotcha hook. That was a really good name. I don't know who said that, but you should consider yourself really cool. So I'm going to go to our hook. And you can see, for this hook, you can see all the different times it ran and when it ran. So it ran for this old stack, ran for this new stack. You can also see if it failed or not. Oh, they all failed. Surprise. But I'm going to change this hook to actually run not just when we create resources, but when we create a change set. So are folks here familiar with change sets? Raise your hand if you know what they are. Cool. Change sets are basically CloudFormation's version of a Terraform plan. I'll show you, rather than just describe it, I'll show you how it works. So I'm going to go to CloudFormation. I'm going to upload my template. And change sets rule. And doot. Boop. OK, so instead of clicking submit and having CloudFormation go try to provision everything, I'm going to create a change set. And this change set will show me, hey, here are all the things that would happen if you tried to apply that. So this change set says, hey, if you tried to apply this change set, you're going to create a DynamoDB table, Lambda execution rule, Lambda function. But my change set is actually in a failed state because my hook failed. My gotcha hook failed, right? So this time, what's cool about this experience is that you get every single one of the rules that I ran, they run early, and you can see all the details of how to fix this stuff directly. So if I go back to my gotcha hook, I can look at this hook run. And you can see well, look, we fixed a bunch of stuff. We fixed the public read prohibited, and we fixed the object lock. But now you can see in one place, hey, your DynamoDB table has to have SSE enabled, and your IAM, I have a role with an admin policy. And the fix for that is remove it, which makes a lot of sense. So just for fun, I'm going to show you, through the power of movie magic, I've already fixed all of this, actually. And I'll just show you, ta-da.
How it works.
Yeah. What happens in the delightful case? I'll show you. Cool. Okay. So in this case, you can see that my change set can actually run. I can execute it. You can see that our hook passed because we fixed it, and it was truly delightful. So that's kind of the experience that I have as a team lead of writing CloudFormation Guard to make sure things work. I want to show you one more thing real quick because CloudFormation Guard is really cool, but not everyone wants to do it. We have another hook called the control catalog, and this is meant for compliance checks. So if we look at this, basically has a bunch of pre-built policies So I can, I can just, so instead of having to write the guard myself, Amazon owns and runs these rules, so we maintain them. I can basically say, hey, like this bucket has to have S3 enabled, versioning enabled. It has to have server-side encryption. And Sefi's going to show you more about this later. But what's really cool about this is that like these policies are also grouped by like their compliance framework, right? So I was talking about NIST earlier. So you can see like, oh, this rule is applies to the NIST framework. And I'm super excited about security. So I could just create this hook with all of these proactive controls already enabled, and I don't have to write a single line of code, right? Like you can take this home and just enable this hook in one mode with all these controls turned on and see like, oh, what resources are people in my organization creating which are not compliant?
And also, if you work in a multi-accounts environment, you can run it on all accounts.
Yeah.
How many of you are working with multi-account environment from security perspective?
Yes.
How many of you implement Control Tower? Ooh, cool. So after I will show some cool stuff.
Yeah. So this is delightful. I'll create this hook. It'll be in my account, and I can play with it and experiment with it. But in reality, like Sefi's saying, like you really actually want to make sure, like apply this to OUs and like enforce it. So he'll show you how to do that later. I love Terraform, and I've been talking a lot. So I'm actually going to hand it over to Sefi to show you how this can work, how you can use CloudFormation Hooks to also run policy and proactive controls for Terraform.
Yeah, thank you, David.
You're welcome.
Let's just fix the credentials.
What's up? Oh. Yes. So yeah, the question is like, why not just have hooks always run on change sets? Is that right, basically? Yeah, that's a really good question. There is nuance. So when we run at the resource level, we're literally about to call the APIs. So we have every piece of information that we need to call the APIs. At the change set time, there are dynamic values that we don't necessarily know. So you don't always have all the information that you need, like that you would need to make a fully deterministic decision. So an example would be like, I need the subnet, you're creating a RDS instance, you want to look at the subnet IDs and evaluate to make sure that they're correct and like allowed. If your CloudFormation template references the subnet ID as an output of like the subnet resource, there's no way like you can know that until you create the resource. So basically, like it's sort of like a filter. You have less information at change set time because properties that are only evaluated after a resource is created are not available yet because you have not created the resource. But at resource time, you have all the information. So usually, like for our hooks, we run them on both, and we usually write our rules such that like if the value just isn't present because it's like not because it hasn't been resolved yet, we just skip it.
And that's how I would think of it. You write it in such a way where the change set knows that certain values cannot be elaborated at this time, so it skips it and then it just saves it for the hook.
Yes.
It's still default to have the change set there.
Yes.
That's what I'm saying.
Oh yeah, I mean that's fair. I think we just like change sets is like the change sets hook launched last year, and so like we don't have like a super opinionated approach yet with like the wizard. It's just, but it's like a fair point. Like I think if I were to create a hook, like the defaults would be like resources and change sets. The reason why like sometimes we don't make that is because like Sefi will show you that like we're gonna apply this to Terraform now, and Terraform doesn't have change sets.
Yeah,
so like
it's a little bit
it's a good point. Yeah, like I think for most, if you're using CloudFormation, I would almost always just choose all of the things. So like resources, stack, change set. So. Good. Oh. Okay. So the question is like what do I do with exceptions, basically? There's a few things you can do with exceptions. So I skipped through the hook creation screen like pretty quickly, but in there you can basically exempt certain stacks. You can just say, you know what, this is fine. The other thing that I didn't show you is that in the guard hook, you can provide this thing called like an input parameter, which is so a common thing that we see is basically like like this stack and this particular bucket are exempt. And so what you would do is like you would put that into like a file, put it in S3, and then you tell your guard hook to like read that file. And then that data becomes like available as like context to write your rules. Another thing is if you look at the guard repository, if there are rules that you think are like useful, but like developers should be able to override them themselves if they think, if you look at the guard repository, basically like you can include additional metadata in the CloudFormation template at the top, being like, I acknowledge this, but I don't care. And like you can write your rules such that like it's like, okay, as long if there's like a suppression rule in the template, I'll skip this rule. But it's up to you. But yeah. Good question. Was there another question over there? Cool. Yes. So Terraform plan is like almost exactly equivalent to change sets. The weird thing with Terraform plans is like we don't actually, like that's on client side, so we have no interception point for that, so we can't apply hooks at that level. So we can do it with resources in Terraform because we have the AWS Cloud Control Provider, which basically just takes. Yeah, and Steffi's going to show you that right now, so I won't
show you.
It.
David, you will help me.
Yeah.
So before we start, I will run Terraform apply, and we're going to fail, okay? Everybody relax, we're going to fail. This is one of the reasons we're doing it. And then we start working. So I have two rules. If you saw the template of David before, of the CloudFormation template for the Lambda, he used deprecated runtime. I think not 16, because Kiro created it for you. So basically, I created some guards that check exactly which runtime is inside the resource, because we don't want to run deprecated runtime. And you see that, as David mentioned, we use resource type AWS Lambda function. And then we take the runtime variables. But from where we take it? We take it from the CloudFormation template reference. You're familiar with it? Who is working with the CloudFormation? Yeah? So also in the rules, you can see which variables you can take from here, and then just paste it inside the rule. For example, here you can see all the version of the Lambda. But now that the Terraform is running, I want to show you how we're going to use the AWS CC to create the hook. Okay, so we'll do it really fast. We're going to create a hook with guard. Okay, I'm going to browse the files that I zipped before. Okay, and I'm going to use the same bucket for the results also. And of course the name, but in the hook target, we're going to use the cloud control APIs. Okay, which basically is going to catch the Terraform applies that we're doing. And it's exactly the same thing like CloudFormation Hooks. We can choose what action we want, create, update, etc. And we can choose if we want to run or fail. Okay, so I already created one of those hooks. Now let's see what happened to our Terraform. Ooh. Okay, so basically what we did here, I also used Kiro to generate it. Okay, we're going to use to try to create a Lambda with runtime of Node.js 18, which is deprecated. And also, we're going to try to deploy an S3 with a lot of missing variables like block public access, bucket encryption, etc. Now, there is something new. The screen is a little bit big for me. It's OK? You can see like this? You can see that also in the Terraform, in the IDE, you can see the reason of why the hook failed you. OK? For example, in the S3 bucket, you can see that it's failed because S3 encryption required, S3 no public read, and S3 version enabled. Like David showed before in the GUI, you can see to the ID. But if I want to see the exact reason, all the output of this hook of what happened, so I can just take this JSON, add a kind of a dash, and then it will be to my std out over here. Okay? So if I'm a developer, I can use it for my VS Code, and if I'm a ClickOps guy, I can use it from the GUI, right? Okay. What else we want to see? Just show you from here also. See, it's exactly the same like the CloudFormation Hooks. It's working the same with Terraform, right? Okay. Basically, this is a demo of Terraform.
Yeah. The cool thing, so Sefi used the AWS CC provider, which is different from the AWS provider. With the AWS CC provider, basically it uses Cloud Control API under the hood, so it takes the resource and it sends it to CloudFormation to create it, rather than orchestrating API calls directly on the client side like the AWS provider. Since it sends the entire payload to us before it gets created, that's why hooks can run at the same time.
That's why you can catch it before.
Yep.
Exactly. So you want to show now of how to implement it on organization unit?
Yeah. So any questions about the Terraform implementation? Oh yeah, can you show the provider?
What do you mean provider?
Yeah. Yeah, so the required provider here is HashiCorp AWS.
AWS CC.
Yeah, instead of AWS.
This is a different because, as David mentioned, we want to catch it before it creates a resource. So it's not doing Terraform API calls straight to the AWS account. It's sending the payload, and then you can block it before it happens.
Yeah.
Basically, all of these hooks, if we start this talk, when we talk about it, it's to stop people to get in call after hours because they create something that they didn't supposed to create, and they didn't even know that they supposed to do it that way.
Yeah.
Right?
Yeah.
Yeah.
Great. So this is not a drop-in replacement. If you have existing Terraform and you're using AWS, the AWS provider, Hooks is not very helpful for you. Going forward, so our relationship with HashiCorp is HashiCorp owns this provider, but it's a partnership with us. And one of the main reasons why we partnered with Hashi to create this is not for hooks at all. That's just a nice side effect, but mostly around coverage. So we've noticed, and our customers have noticed that new feature launches in Terraform can be they can lag. They can get there before AWS support, AWS and CloudFormation support resources. But we've noticed a lot with AWS. We have mandates on launching with resource support immediately. That there's this growing gap of sort of medium to lower popular resources, and Terraform just never getting support. And so to help with that, we basically said, hey, yes, use AWS provider for stuff if you want, but also you have access to the CloudFormation versions as well, so you can mix and match. But and a side effect of that is that with hooks, you can also intercept governance-y stuff with that. But yes, to your point, there's not a lot of sugarcoating on that. If you're using the AWS provider today, we can't put hooks in that call path. The only option you have really is sort of IAM and SCPs to do governance-y stuff. But those are
RCPs, declarative policies. There's a lot of options that you can do it in the organization level through a control tower to block from this thing to happen.
Yeah. Cool.
Cool. Any
questions? One more question, yeah. Yes. Change sets and hooks and the control hook and Lambda and guard hook, all those things are also in GovCloud, the China regions and the secret regions as well. Yeah, we had a really interesting launch in CloudFormation this last week or this week. I don't know what day it is. Where we do early validation. So basically, we'll check before a CloudFormation stack runs to make sure that the resources that you're trying to create don't already exist, or some properties aren't set correctly. It's sort of a developer experience thing, but it's built on top of hooks. So we are considered part of launch blocking for new region builds. So hooks and all of these features are there for all new regions. Cool.
Would you like to see how to implement it, controls and hooks on organization? Yes. Cool. Okay. So we're going to close all of this. So I have a multi-account strategy, a landing zone in this demo environment, of course. And we're going to get inside to the management account. Let's say up, and we will go to control towers. Everybody familiar with control tower? Yeah, cool. And we will go to control catalog that have a new face now, which is amazing. And we're going to filter the controls for proactive behavior, okay? And then we can choose whatever all we want. Any specific, I don't know, Redshift stuff. And you can see exactly what framework, like David mentioned before, and which regions are also deployed. If you work in a region that this control is not available, you cannot deploy it, basically. And we're going to do enable control. And here we can see also the selected control. You can choose multiple controls. You don't have to choose just one. Just for this demo, I choose one, so it will be faster. And then we have the organization units that we can choose on. So let's take Sandbox, for example. So I can just, let me see that we have a count over there for a second. Okay. Sandbox. So we choose the OU, we can tag it, and we do enable controls. It will take several seconds until it will be provisioned. You can see all the controls that I would implement it here. Okay, we'll give a second. And the cool thing about it that you can, from here, you can choose from security perspective if you want specific framework, and then you can enable those controls. You need to do it carefully because you do want that your team will succeed to do stuff. And let's see if it's work now.
Yeah.
Yeah, we'll go to the account, reinvent.
The cool thing about like this approach versus the one I showed, like I was enabling the hook in like an individual account. He's enabling it for like an entire OU, and like there's a like resource policy on that hook that basically means you cannot turn it off unless you are like in the root account. So.
Okay, so you can see we have the guard full governance that I built before, and now we have also the control tower hook that's managed by control tower. So under this OU, I have like 5, 6, 10, 100 accounts. It will implement to all of these accounts, and of course, nobody can be deleted, and that's why you can secure your environment from a management account.
The nice thing about the control catalog through Control Tower 2 is that this talk is called from like reactive to proactive. The Control Tower catalog also like it groups things by control objective. So like here's the thing, like the control objective that I want to accomplish, like no public S3 buckets. Through the control catalog, like you can enable the proactive version of it, but you can also enable the reactive version, the detective version too. So it's like a defense in depth thing. Like if someone goes to the console, like they're not going to get, or using the AWS provider in Terraform, they're not going to hit hooks. So you still probably want detective controls as well.
Basically, you want to implement all the kind of control. It depends on the environment and the security requirements. But what I do want to show you here is that you have common controls from Control Tower, of course. It's also divided by services. That means if you're using ECS, EKS, EC2, and stuff like this. Frameworks. And you can see also which controllers are enabled. This is also something cool to see exactly on which accounts it's enabled. If you want to, I don't know, investigate, how to say,
like look.
Investigation.
Yeah. If you want to look at like the impact that this is having on like different accounts that you have.
And which accounts. Exactly, and which framework also, which is also cool.
Yeah.
Any questions?
A little bit increased from 100 deployable controls at once that are into that. What was like 50 back a year ago? And then
From the quarter?
from year or
Yeah. Did you open a support case?
I did, yes.
I think I'm pretty sure that they use the same like implementation of the control hook as we have, and we completely rewrote it. And so I'm pretty sure that limit is now gone. We should double check to
Yeah,
make
we
sure.
will check it.
Yeah. But
We'll take it offline afterward and we'll take your details, no problem.
yeah, they had to rewrite it basically for like we rewrote the implementation to support this. Because actually it was really funny. The hook runtimes used to be constrained to like Java and Python. We added Rust. Guard is written in Rust. All of these controls are written in Guard. So we were able to like they were doing truly gnarly things with the JVM in order to like run Rust. But we rewrote it, and now I think probably a lot of these limits are gone. But we should definitely double click for that for you.
Any more questions?
Oh, there's a question in the back. Of course, it's CloudFormation. Just kidding. They're paying my bills. I would say use what's right for you and your organization. I think for me, for CloudFormation, you get a lot of safety and like auditability built in. If you're using organizations and you have to manage an organization, it's really well integrated with that. There's a product called StackSets, which basically you can like provision CloudFormation stacks across OUs and accounts by default. I would also say, and I don't think this is a huge secret, so I don't mind telling you, that like most CloudFormation customers are also Terraform customers. So like a lot of shops just use what's right for like the right thing.
Yeah, and basically also you have, if you want to multi-account structure, you have the solution of Terraform, the account factory for Terraform, which is also very good.
Yeah, but what you run into when you like use Terraform, just from an AWS perspective, like I love Terraform, is that like a lot of work that we do, like hooks, like are like it's supported with an asterisk, so things like that sort of happen. Yeah, so yeah. Also, I love the CDK, so like HCL is fine, but like I love the CDK, and I love like writing my code in TypeScript. So yeah. Cool. Any other questions, y'all? Oh, here, yeah.
From the control tower side, can you make it warn instead of fail?
It's a wonderful idea. Yeah. So technically yes, and we're working with them to figure out like what the right experience for that is. I think some of that work is like under the covers, like the Hooks team has been doing some work on like backport, like sending invocation history backwards to like the root account, basically, so like you can actually do some observability on it and say like, hey, like okay, this is failing for 100% of the accounts that it is deployed into. So we're working with them to support that. So that's good.
Observability seems to be pretty challenging from our side because there's all the drops to a specific log file and trying to
Yeah. Yes.
You want to share?
Yeah. I will show you one thing. So we did launch some like UX improvements. It's still not. I will tell you two things about observability. One, connections. Does anyone have any feedback for Amazon?
Yeah.
One is that we don't talk about this much, but you can actually integrate. Like there's an event bridge hook for hooks. So like you can create anytime we invoke a hook, like we send invocations to EventBridge, you can route it to wherever you want. This is how we're implementing this under the hood for Control Tower. But also, so you can see, like we've launched this new screen, basically. I don't know why I turn off results. Basically, you can see all the invocations that happen in this particular account and see like whether they passed or failed and like what the validation error was. The same for the exact reason of like, it's actually really difficult without something like this to see like the impact that a warn hook is having. Yeah, so, and observability is sort of like the next, is observability in organizations, more integrations is sort of like the next set of features that Hooks is like really like diving into. But yeah, cool. Any other questions? Cool, remember to like and subscribe. I mean, fill out your survey on your app for this session. If you give us great reviews, they give us raises. If not, they put us back in the pen. So,
yeah. Thank you very much.
Yeah, thank you so much. Thank you.
This is in the